Today we're talking about solving linear systems by elimination. So another way to solve linear systems algebraically is the elimination method. The elimination method functions by either adding or subtracting the two equations to get an equation with only one variable. So the other variable is basically eliminated. So our first example here, solve the linear system by elimination. We have one equation here and we have another equation here. Our first step, write the equations so that terms appear to be in a column, and we have that kind of pre-written for us already. So our first equation, 4x minus 2y is equal to negative 4, and our second is x plus 2y is equal to 9. The next step here, add or subtract the equations to eliminate one of the terms. So basically what that's saying is, okay, what do I do between these two in order to eliminate either the y term or the x term? Well, eliminating means making one to 0, right? So if I look at my y term, they both have the same coefficient. They both have the coefficient of 2. So that's really easy to work with in terms of, okay, how do I eliminate this? What operation do I perform? Add or subtract these two in order to eliminate themselves. Well, if I have a negative 2 and I go ahead and add a positive 2, I'm going to have a 0. The other rule that we have down here, if they have the same signs, you subtract them. If they have different signs, which we do here, a negative 2 and a positive, you simply add them. So I'm going to add these two equations together. So I am going to add 4x plus x, and I'm going to get 5x. Negative 2y plus 2y. Well, I'm going to have 0 y's plus 0 y. And then negative 4 plus 9 gives me a value of 5. Right? So all I did was simply add these together. Anything multiplied by 0 is 0, so I'm just going to rewrite that without the y. So I'm left with just the x value, or I've eliminated the y term. And then I find x to be a value of 1. Next step, substitute the value into one of the original equations and then solve for the other variable. Well, I found my x, so now I need to find my y. Plug it into one of the original equations. I'm going to do the second one here. X plus 2y equals 9. I know x is equal to 1. 1 plus 2y equals 9. 2y is equal to 8. And then divide both by 2 to give me a y value of 2. So I have my x value and I have my y value. So my point of intersection, sorry, that's not 2, that should be 4. Y is equal to, my fault, 4. There we go. So my point of intersection is 1 and 4. If I go ahead and graph the linear systems and compare it, just to kind of visually see what this actually means, what I can do is I can find the 2 points. I can find my x-intercept and I can find my y-intercept, right, by setting one and the other variable to 0. So to find my x-intercept, or basically where the line touches the x-axis, I know the y value is going to be 0. So if I set y to 0, I simply get 4x equals negative 4, which gives me an x value of negative 1. To find my y-intercept, well, I set x to 0. I end up getting negative 2y is equal to negative 4. Y is equal to 2. So I have my x and I have my y. I'm going to just go ahead and plot that. X is negative 1. Y is positive 2. There. And then my line basically looks like that. That's not what I want. My line will look like this. Something like that. There we go, that's a little better. So then this equation is 4x minus 2y 4x minus 2y equals negative 4. Negative 4. The other equation I have, if I find my x-intercept and I find my y-intercept, those would be my 2 points. If I set my x-intercept, I find my x-intercept, I set my y to 0. Well, that would be x is equal to 9. So that's a pretty easy one. Oh, right there. And then set my y-intercept. That would mean x is 0. So that's 2y equals 9, which gives me a y value of 4.5 or 4.5, which is about right here. And then if I'm going to draw these going through each other, I end up passing through that point of intersection. That's not what I want. I end up passing through. Oh, there it is. That's easier to see. That's a little better. Best I can do on a screen here. So we can see how it actually passes through the point of 1 and 4, right? You don't have to graph it every single time we do elimination. This is just to verify that, hey, we found our point of intersection using elimination. If we go ahead and plot that, we can then visually see that that is in fact correct. So our next example, solving this linear system by elimination. I have x plus 2y equals 12 and 3x plus 4y is equal to 4. Write the equation so that the terms appear in a column. Done. Now you'll notice that the x term and the y term do not have the same coefficient. They don't have the same number value next to it. So I have to manipulate or change either the first one or the second one in order to have the same coefficient as the other equation. So I'm going to take my first equation there and I'm going to multiply it by 3. So if I take that first equation and I multiply it by 3, everything in this equation is multiplied by 3. So 3 times x gives me 3x. 3 times 2 positive 2y gives me positive 6y. And then 3 times 12 gives me 36. So now I have my new equation, and if I take that other equation and bring it down, that other equation was 3x plus 4y equals 4. Now I have a term, my x term, with the same variable of 3. They both have the same sign, they're both positive, so I need to subtract one equation from the other. So when I subtract one equation from the other, I end up getting, well, 3x minus 3x is 0x. 6y minus 4y gives me positive 2y. 36 minus 4 gives me a value of 32. Now I can then solve for my y, which is then 16, by dividing both sides by 2. Now that I have my y value, substitute the value into one of the original equations and solve for the other variable. So I have my y equals 16. I'm going to use that first equation there. Change color. I'm going to use x plus 2y equals 12. So x plus 2, I know my y is 16, equals 12. This gives me x plus 32 equals 12. I end up getting an x value, 12 minus 32, of negative 20. So I have my x value of negative 20 and my y value of 16. So my point of intersection, negative 20 and 16. Our final example, bit of a word problem. Kayla is selling tickets to the annual dance competition. On the first day, Kayla sold 3 adult tickets and 5 child tickets for a total of $70. On the second day, Kayla sold 12 adult tickets and 12 child tickets for a total of $216. How much does each ticket cost? So we have our our let statement here. So X is the adult tickets and Y is the cost of children's tickets. So if I look at the first day, Kyla sold 3 adult tickets and 5 child tickets for a total of $70. So if I'm going to write that, that would be 3 adult tickets, 3X, and she sold 5 child tickets for a total of $70. And then on the second day, she sold 12 adult tickets and 12 child tickets for a total of $216. 12 and then another 12 would equal $216. So if I'm going to solve or determine how much each ticket costs, I can use elimination. But you'll notice that my terms don't have the same coefficient. So I need to manipulate one of these equations so that either the x term or the y term have the same coefficient. Well, if I take 3x, I can turn that into 12x by simply multiplying it by 4. So what I'm going to do is I'm going to multiply this entire term or this entire expression by 4. So I end up getting a new equation of 12x plus 20y equals 280. So with my third equation, I am then going to subtract out or take away from it this equation. So the other one I have, I'm going to write that in green just to be consistent. 12x plus 12y equals 216. So when I go ahead and try to eliminate my x, I know I need to subtract because they're both positive coefficients. So when I subtract them, 12x minus 12x gives me 0x. 20y minus 12y gives me positive 8y. 280 minus 216 gives me 64. Now I'm left with, well, this cancels out. Y, if I divide both sides by 8, gives me a value of 8. So I know my y value is 8. So then I'm going to sub my y value. I'll write this over here. Sub y equals 8 into, I'm going to do the first one, into equation number 1. So I end up having 3x plus 5 times 8 is equal to 70. 3x plus 40 equals 70. 3x equals 30. X is equal to 10. Now, if we remember what each represents, what this means is that an adult ticket costs $10. Child costs $8 based on using elimination. So our big takeaways from this would be to make sure that the terms have the same coefficient value. If they don't, we need to manipulate that by either multiplying each term by the same factor. Once we have that, then we can look at, okay, same signs, we subtract different signs, we add them together to try to eliminate one variable so that we can easily solve for the other.